Hi, this video we're going to look at using a compound change or a compound increase or decrease, but using that in reverse where you are told the amount that you have left after a certain number of years and you need to go back to work out the original. So hopefully you know that to calculate a compound change, you need to do the original value multiplied by your percentage multiplier, which is what this D is here. So whether you are increasing and it's 1 point something, or you're decreasing and it's 0 point something, you have a decimal multiplier. And then the power is the number of years, months, periods of time that you are increasing, or the number of times that you are increasing by whatever percentage, or decreasing by whatever percentage. And then that gives you your new value, your final answer. Hopefully we know how to use that. I haven't done a video on that yet, but I will. So hang fire if you're not sure about compound change at all. But these are just, I'm going to make 3 videos just to go through the kind of special cases or the different types of questions you could be asked that are not as straightforward as just using that equation. So there's 3 different types. The one we're looking at today is reverse, so being asked to find the original amount after a repeated change. That's what we're doing today. Then we'll go on to look at finding the number of years or months it takes to get to a certain value. And then finally, we will look at how to find the actual multiplier or the percentage based on your original value, your new value, and the number of years that it has, well, the number of years difference between them. And then we can use that to find the multiplier or the percentage. But today we're focusing on a reverse compound change. So we've got a question like this. I'm going to go through it. And then there's another question which I'd like you to pause the video, try it, and then watch the solution, just that you've had a go at one yourself. So watch this one first, then try the next one before you watch the solution. So I invested some money into a bank account after 3 years with 50% interest, which is a very unrealistic interest amount. But anyway, after 3 years with 50% interest, I have £3,375. What did I originally invest? So based on the original, the compound change equation, I have some number which I'm going to call X. I multiplied it by my percentage multiplier. So interest is an increase. I'm increasing by 50%, so 100% as your original, plus the 50%. I'm doing 100%, add 50% because it is an increase, is 150%, and then I change that to a decimal, is 1.5. So that's my decimal multiplier. I'm doing 1.5 to the power of 3 because it's 3 years, and then that gave me an answer of 3,375. I need to work that backwards to work out what X is. So to get X, I'm going to do 3,375 and then divide it by 1.5 cubed. Okay, just divide that straight over to the other side of the equation. That gives me, when I put that in my calculator, that gives me £1,000. So my original investment was £1,000. And as you can see, because it's increasing by 50% each time, it's gone up quite a lot in 3 years. You've more than tripled your original investment because you are increasing by 50% each year. Like I say, unfortunately, there's not many banks in real life that will give you an interest rate of 50% because that is a lot. But anyway, the next question then, I'll read it and then I'll pause. You pause the video, try this question. So based on what we've just done there, you try this one and then I'll go through the solution so you can check if you got it right. So we've got a population of polar bears. It's decreasing by 10% each year for 5 years before dropping to 23,620 bears after the 5 years. So it started at something, decrease by 10% each year for 5 years, and you're left with 23,620 bears. How many bears were there originally? So I'm going to pause here, pause the video, have a go yourself, and then come back and see if you were correct. Okay, so I hope you've paused the video, and now I'm going to go through what the solution was. So again, setting it up the same way as we did previously, the number of bears there were originally is the unknown, is the value we're trying to work out. So I'm going to call that x. I multiplied it by, this time it is a decrease, so I have my original 100% of the bears, and I'm subtracting 10% each year. That leaves me with 90%. If I change that to a decimal, that's 0.9. So that's my decimal multiplier. I'm doing x multiplied by 0.9 to the power of 5, because it's 5 years, and that gave me 23,620. I need to divide that 0.9 to the power of 5 over to the other side to get what x is. So x is 23,620 divided by 0.9 to the power of 5. When I type that into my calculator, I get 40,001 bears. That is a nice number, 40,001 bears. But that's how many bears there were to start off with before they started increasing to 10% each year. So I hope you got that right. I hope this helped. This is the easier way, or the easiest of the 3 methods I'm going to show you in these videos. Going back to the original value is easier than trying to find the number of years or trying to find what the percentage was, but it is more difficult than just a straightforward, I invest this much for this many years at this percent increase, how much do I have at the end of the number of years? That's your basic compound interest. This is the kind of the next step up from that, and then we've got 2 more steps above that, which I'll go through in the next 2 videos. But I hope that helped. Have a lovely day. Thanks for listening and watching.